Okay, folks, today's video here is not a full review of the materials and notes we've already taken, but as a highlight to remember some of the things that we're going to be on the day 2 section, the non-calculator section of the final exam. So here are the main things we're going to look at. The first is functions, general equations, and shapes. And what I'm going to have you do in accompanying this video is you're going to take some information down on, you can write on the back page of your packet or one of the pages of your packet. At the end of the period, you'll take a picture of it and you'll send it to me via Remind. If you don't have a device, you can have someone else take a picture of it for you and put your name on it so I'll know I'll receive all the information. So I'm going to pause this for a second and draw some general shapes. So please remember these might not match up exactly to your notes, but they are going to be stuff you'll need to know. So I'm going to pause this again. Okay, so we have, obviously, hopefully you're all good with the linear function. We're not going to worry too much about that. It's general equation, y equals mx plus b, or y equals mx minus x1 plus y1, you mix e. Next function is obviously the quadratic function. An odd degree is going to have ends going in opposite directions. So believe it or not, two of these are odd degree functions. Which two are they going to be? They're going to be this one right here, obviously, because it goes in two opposite directions. But guess what? A linear function is an odd degree function. It goes down in one direction, goes up in another, and that makes sense because it's to the first power, which is an odd degree. An even degree function looks like that one right there. So on the back of your page, if you could sketch one function, that's that, and another function, that's that, but just make sure they're not the same as the one that are on this page right here. If you'd like to pause for a moment and sketch them, go right ahead. Okay, on to the next three, which often differ from each other. I'm going to sketch the three. Okay, so the question is, who's who? So what I'm going to identify first is I know that exponentials and logarithmics are inverses of each other. And I know exponential always passes through the y-axis. So this one has to be the exponential function. Logarithmic functions are opposite that. So instead of passing through the y-axis, it's going to pass through the x-axis. That's how it looks right there. And then a power function, which is of the form y equals ax to the b, is either going to pass through the origin, or it is not going to pass through the origin or any of the axes at all. And what makes them that way is, for example, this one could be x, could be that, but this one could be, with the difference being that information right there. Let me redraw that so I can make it clearer. There we go. Okay, so the next thing you're going to write down on your page is how you can tell the difference between a power function, like in part A, and a power function in part B from its equation. If you were to look at this equation here, what makes one pass through the origin, this one, and makes one not touch anything at all? Please write that down in your notes. Another type of functions that will come up are direct and inverse, or sometimes called indirect. For x, if you think of the meaning of the term, this kind of makes sense. Direct means it's going to do exactly what it says it's going to do. So as one goes down, the other goes down, or as one goes up, the other goes up. And on inverse, inverse is going to be the opposite, or indirect. As x gets bigger, y gets smaller, or as x gets smaller, y gets bigger. Nothing to write down for that one. Now, the other type of function I want to talk about really quick, two other types, a rational algebraic. And all that means is there's a ratio in the function. That's all that means. X squared plus 2x plus 7 over 9x plus 6. There will always be one function, one polynomial, over the top of another polynomial. This has values everywhere except where the bottom is equal to 0. If the bottom equals 0, you'll have some type of discontinuity, but that's not important for this section right here. And then the last type to think about is, last step in this review to think about are our logistic function. We remember that they're the best of both worlds. So what they do is they start by increasing rapidly, and then that rapid rate flattens out. And however high this function goes, let's say this one went up to that number, the point of inflection is going to happen at that number. So the third thing I'd like you to write down on the page is if you know the maximum height of the function, where is the poi? In general terms, describe where that poi is going to be. This picture and the number should indicate to you where that's going to happen. Okay, we're going to look at transformation of functions from the view of a point, of a couple of points. Now, some of these transformations are horizontal and some are vertical. I'm labeling each transformation that's occurring. Okay, so two of these transformations are horizontal. Which two are horizontal? If you said you are correct, those ones are, what's that? You say I'm not right? I agree with you. Great work. I would say it is this choice and this choice are the horizontals. And why are those the horizontals? Because the transformation is taking place, almost wrote it down wrong, inside the parentheses. I wrote inside the parentheses. And so what happens is going to be the opposite of the actual transformation. That means that the other two are going to be vertical, and they're going to be the same as what they say. And they're there, those because they're on the outside of the transformation. So let's do the horizontal ones first. Remember, horizontals are only going to affect the x-axis, x values, and the vertical ones are only going to change the y values. So doing the horizontal ones first. The first one is a horizontal translation plus 2. So I'm going to add 2 to the x value. Y value didn't change. Over here is a horizontal dilation times 1/2. It's the opposite of what's going on. So it's going to go to the point 2, 8, and you'll notice only the x values changed. Okay, so now let's do the vertical transformations for that one. I already know I can write something down because on these nothing's changing in the x direction. I'm going to put down the original x value, and I'm going to add 3 to the y value for this one. And I'm going to multiply by 4 on the y value for that one. And you'll take a look on those, only the y value changed. So let's take a look at the next problem right here. What I can do beforehand is write this information in. It's a parenthesis, by the way. I wrote those in because I know there was no change in those directions. Okay, so for the ones in the x direction, it's a -2 plus 2 goes to 0. Over here, it's -2 times 1/2, which is -1. And in the y directions, it's going to be, I'm going to add 3 to -3 and get 0. And the last one, I'm going to multiply the y by 4 and get -12. So the next thing I'd like you to write down is just write down which two, number-wise, are horizontal transformations, and then write down which ones were vertical transformations. So sometimes we can have one transformation in the y direction and one in the x direction. And remember, they don't affect the number of the other, x affects only the x and the y affects the y. So we have a horizontal dilation times 2. And we have a vertical translation plus 3. So that would mean when I go to make this point, for the x value, I'm going to multiply it by 2 and get 4. And for the y value, I'm going to add 3 and get the value of 12. Okay, the next one is not much help I can give you with other than to make sure you know how to sketch quadrant 1 of the unit circle and get information about sine, cosine, and tangent from there. So the big thing is to make that unit circle correctly. I start by knowing the point 10 is on there and the point 01 is on there. Now what I do is I know how to go up from here because in the x direction it starts at 1 and goes down to 0. So the numbers in this in the x values are going to go down. So it's going to go radical 3 over 2, radical 2 over 2, radical 1 over 2, which you can just write as 1 over 2 if you want, comma. I know the y values are going to do the opposite. Radical 2 over 2, radical 3 over 2. And I have my values right there. Pretty straightforward. Now the question is what angle measures go with those? Well, I know this is 0 degrees, also 0 radians. I'll write in degrees first. 0 degrees. I know it's 30 degrees, 60 degrees. Oop, did I mess up? I did. Good job. Let's go back. I'll go to 60 degrees. It goes to halfway is 45 degrees. And I go 60 degrees, and then I go 90 degrees. Now I know I didn't write mine in here very well. Didn't give myself a lot of room. I'm also going to write the radian measure on there. And just remember, pi radians is 180 degrees. So pi 180 divided by 6 equals 30. 180 divided by 4 equals 45. 180 divided by 3 is 60. And 180 divided by 2 is 90 degrees. So you can remember from this chart, SI and Y, sine is Y, cosine is X, and tangent equals sine over cosine. So I can find any value I need using that information right there. For example, if I want the sine of 45 degrees, I'm going to go to the Y value at 45 degrees, which is radical 2 over 2. If I want the cosine of 30 degrees, I'm going to go to the x value at 30. X value at 30 is radical 3 over 2. And if I want the tangent at 60 degrees, it's going to be the sine, which is the y value, at 60 over the x value at 60. So it's going to be 1/2 over radical 3 over 2, which you can totally leave in that format. But remember, with fractions, we can also equals 1/2 times 2 over radical 3. They cancel out, and you get 1 over radical 3. You can leave it that form. That's fine with me. And really quickly, for basic vector info, key things to remember. The things we're going to work on are the following. We're going to make sure that we know if we have vector v, and it's 3i plus 4j plus 2k. We can find its magnitude really quick. Magnitude of v equals radical 3 squared plus 4 squared plus 2 squared, which equals radical 9 plus 16 plus 4, which equals radical 16 4 is radical 29. And I'm not going to do all the vector stuff in here right now. I've just got a couple things to do. The big thing to keep track of, make sure that when you're finding the length of a vector, when you square the things, if v was equal to 3i minus 4j, this is what tends to happen often. People go vector v is equal to square root of 3 squared minus 4 squared. And then they give me back radical 9 minus 16. So they say the answer is radical negative 5. Well, something went wrong there, didn't it? It did. You have to remember always that when you're squaring something, it's in parentheses. So any negative answer is always going to come out and be positive. 9 and 16 is radical 25, which is equal to I. Please remember when adding and subtracting vectors, just make sure you combine the correct components. So really quickly, if I have the following two. To find this information right here, first I have to figure out what 3a is, and then I can subtract off 2b. And it's going to combine the like components. Well, 3a is going to be the following. I'm just going to multiply each component by 3. 6i plus 9j plus 12k. And then 2b is going to be 3 times 2 is 6i. Negative 2 times 2, negative 4j. 2 times 5 plus 10k. And I always debate back and forth on whether I do this or not. There's 3a. If I turn this into negative 2b, all I'm doing is changing the signs of everything. So this becomes negative, this becomes positive, and this becomes negative. I think it's a better approach when you're combining the vectors. And now I'm just going to put 3a together with negative 2b to get my answer. Let's see if I got this right. I've got a 6i, negative 6i. They're gone. You can write 0i if you want. You also don't have to. 9j, 9j and 4j equal 13j. And then we have positive 12 and negative 10 equals plus 2k. I can leave that like that. The length of that vector. First we find the vector on the inside, and then we do the absolute value to find it. It's going to be the square root of 0 squared plus 13 squared plus 2 squared. I could solve that out and leave it there. Remember, an opposite vector is a vector in the opposite direction. Same components, different signs. So if that's vector v, negative v is going to be negative 3i minus 4j minus 2k. And what's the difference between a position vector and a displacement vector? It's all about where it starts. And this will be the last thing you'll write in the on the page. This is a position vector because it starts there. This will be a displacement vector because it does not start there. So the last thing to write on the back of the page is to tell me what the difference is between a position vector and a displacement vector. Now, I'm sure I made a mistake or two in here. Feel free to send me the information when you get it. This is not meant to replace what we did in the notes. It's just to help add on in there. If you have any questions, I shall see you on Monday. Make sure you take a picture of this and send it to me. It shows me you completed your classwork. Have a good weekend.